Perfect. Okay, we're good to go. So hey everyone, welcome to this workshop today about augmented reality, virtual reality, and we're going to talk about how to build applications. We'll share a few cool demos, and hopefully you'll get a better sense of what are these technologies and how you can build applications for them. You should have received a link to register for our platform for free to get our free premium tier through the link. So make sure you have that to Hackathon organizers. I'm going to talk about Echo a little bit. We're a cloud platform for augmented and virtual reality apps, basically providing developers and companies with tools and network infrastructure to quickly build and deploy 3D apps. We're super excited to sponsor this hackathon and super excited to announce one of the prizes. So if you're going to build some AR, VR application with our tool, you're eligible to win one of the awards. So definitely check that out. Let's start off by saying hello. My name is Alon. I'm the founder of echoAR. We're a New York-based company. I did my master's at computer science at Columbia University and undergrad in computer science and electrical engineering. So obviously a certified nerd. And I'm a big believer in augmented reality, virtual reality, and we're going to talk about these technologies in a sec. So to level set here a little bit, some of you probably have heard about these concepts, but let's level set. Virtual reality, or VR, is basically when everything around you is digital. You're fully immersed in a 3D environment, and everything around you is a computer-generated construct. So you're basically, your vision is occluded, you're wearing a headset, you can't see the real world, and everything around you is a digital construct. As opposed to augmented reality, or AR, in which basically you still see the real world, you're looking to the world through some optical see-through, like glasses or a headset, or through a camera see-through, like a mobile phone. And here we have basically you're able to still interact with the real world, and we're overlaying it with digital assets or digital content to basically enhance the experience, but you're still in your environment. A classic conceptual example of that is the amazing movie Space Jam, in which Michael Jordan is teleported into Looney Town. That's an amazing example of virtual reality, right? Everything around Jordan is a cartoon, everything is digital, and he's able to interact with characters like Bugs in a completely digital environment. As opposed to what happens later in the movie, in which Looney Tunes come to us and we're able to play with them in our world, basically playing basketball with them. They're able to interact with Bill Murray, but basically the cartoons are coming to us as opposed to us coming to the cartoons, and that's AR versus VR. Real world examples of that are obviously more prevalent, like Pokemon Go. A lot of people have probably played it. You're walking around the real world, interacting with digital monsters that are not actually there, but you can still see your environment, you're playing around with Pokemons, pretty cool. As opposed to VR, which we have with Beat Saber, for example. It's a virtual game in which you're able to slash digital objects, you're able to listen to music in a fully digital environment and interact with these digital constructs. Again, super example, definitely check them out if you can. If there's any questions, by the way, about AR, VR, feel free to write them here in the chat. This should be as interactive as it can, so definitely ask questions if you have them. So another example of AR is something that I did back in my thesis project back at Columbia University. We took CT and MRI, converted them into 3D, put them on these smart glasses for a physician to wear called the HoloLens by Microsoft, and basically allow the physicians to get an inside view of the patients, basically looking inside the patients in real time. And that was a phenomenal experience, right? That was a very amazing use case for augmented reality for physicians to see patients' anatomy and navigate through it much better. What they usually had is like fluoroscopy or 2D X-ray, and suddenly with 3D, they're able to see all the vessels, all the chambers of the heart, interact with it, better understand and better navigate through it. And that was an amazing experience for me as an engineer. I literally scrubbed into surgery, which was unbelievable. Like no one even checked my ID. I just scrubbed in, gave that thing to the doctor, started drilling, doc. That was amazing. But to do that, again, the process was to take 2D scans, convert them to 3D models, put them on the HoloLens, and I had to do that every time we had a case. And I had to do one of the things I hate to do the most, and that's waking up in the morning. I had to go to the OR every day at 6 a.m., be there to do that process of changing the content, switching a heart to an aorta, aorta to lungs. And that process was so frustrating. I mean, as a developer, I only wanted to do two things: manage 3D assets and deliver them to an AR device. And if you think about it, that problem is already solved in the 2D world, right? If you think about it, I mean, if we are talking about other use cases for 3D, like shopping or games or data visualizations, they all need to manage and deliver continuous sound capacity. But that's pretty hard. And again, that problem was solved in 2D. And if you think about it, 10 years ago, companies like Heroku created the cloud platform for web applications. For example, you can build a website really quickly. Or 5 years later, mobile apps were all the rage. You're able to build mobile apps really quickly with cloud platforms like Parse or Firebase. So now, 5 years out, so we had web, then mobile, now AR, VR, immersive, MR, call it whatever. We're trying to figure out what will be the best cloud platform to help you build applications like that. And you've guessed it, that's Echo. So we basically built this cloud platform for augmented and virtual reality, providing you with tools and network infrastructure to quickly build and deploy 3D assets. How does it work? So as I mentioned, the same way you don't need to be a web developer to update a blog post, you can just drag and drop an image or video, suddenly that appears on web and mobile. Or let's say if I'm in New York and you're in California and we're both watching some episode on Netflix, we automatically get the best streaming experiences. So we translated these concepts into augmented reality, providing you with a way to manage and deliver 3D assets and get the best 3D streaming experience. And what's interesting here is that we basically have this bi-directional connection between content and target, since you as the user, you can't move an image or a video on a website. But you can definitely move a couch across the room, a 3D couch across the room, or move a Pikachu across the street. And that needs to be updated on the cloud. So that's what's interesting about 3D content, that it's very spatial, it's very aware, it has that extra layer of data of location. So we basically built that with Echo, basically this content management system and delivery network that is focused on 3D content. Again, you can register for free on our website, and you should have seen the link that was shared here to basically provide you with free access to our premium tier for free. Again, we also sponsor one of the prizes, so make sure that if you're building something in AR/VR, use the echoAR platform to be eligible for the award. Okay, so this is a big, quick intro. If there's any questions, feel free to write them down here in the chat. If not, I'm going to move on to some technical demos and show you how you can build applications really, really quickly. In the beginning, it will be like a no coding thing, how you can just drag and drop stuff. Later, we'll do like a more advanced coding workshop. So again, if there's no questions, let's keep going. Perfect. So what we have here is basically on the left, you can see the content management system, and on the right, you can just see my phone. So I'm going to do something simple. After you register, you got to get an API key. That API key will be sent by email. So check your email or spam folder to get that API key. And you're able to load it here. This is my API key. Let's do something simple. I'm going to upload a fan favorite 3D model of the Empire State. Again, we're a New York-based company, so that's a staple right here. I'm going to upload that content. What we do is we're going to take that 3D model that is really suited for 3D printing as well. We're going to build it so it'll work on Android, iOS, Magic Leap, HoloLens, web, you name it. Once it's done and we see it here on the platform, I'm going to open this sample app right here. Most of the developers obviously have their own app, but this is a sample app that we provide, and you're able to download it here under Downloads. Just click that. It will direct you to the Play Store to download that the app. The data is now streamed from the cloud to the device, so the app itself doesn't have the 3D model. The camera is instantiated. It will recognize the floor right here. So let's move the camera a little bit for the floor to be recognized. There we go. And bam, the Empire State is here. I can walk around it, walk inside it, but it's literally here in my apartment. And all I had to do is just drag and drop, click a button, and that's it. Super simple. The Empire State is here with me around the room. Awesome. Now let's say I want to switch it to something else. So what do? So instead of rebuilding the application or doing anything technical, I'm going to go back here, delete the previous entry, upload something else, and it will automatically update across platforms. So let's do that. I'm going to take this apartment building, another New York staple, uploading to our cloud. Again, we build, compress, analyze it, so work on all these different platforms. Once that's done, opening the exact same apps. Again, no technical skills is required right here. It will stream the data again from the cloud to the device, make sure that it works on Android. The camera recognizes the floor, and bam, suddenly we have this apartment building right here instead of the Empire State. And all I have to do is just click a few buttons, and that's it. So perfect. So we saw a mobile example, right? Like how we can stream that to an application. Let's see another example of web. So we work with companies, for example, in the art space that had an art exhibition, and they wanted people to walk into an art gallery, open their phones, and see some cool interaction in AR. And for that, they couldn't expect them to install an app, right? There's a friction there. They actually prefer them to just like walk in, open a browser, and automatically see something without installing anything. No worries. You go to our website /WebXR. It will stream the data to the browser now. So instead of the phone, instead of the app, it will go to the browser. And there you go. We automatically get the same streaming experience through the browser. No installation needed. So we saw web, we saw mobile. There is a question right here in the chat. Is there a Python mobile? Do we? There's a Python. So you can definitely download here. We have a Node.js SDK. We don't have and we have a RESTful API that will work with Python as well. I'm going to share some documentation in a sec, and we'll see how to do that in other platforms. But for now, we saw mobile, we saw web. And now we're also asked if there's any device that we need. So you can just use your mobile phone. That's fine. Android, iOS, it's all good. So we saw mobile, we saw web. Let's see another example of an app built with Unity. That's a game engine that a lot of people really like to use to build AR/VR applications. So it will be very similar. It's just built in a different coding language. We'll see the same building here, right? No surprises there. We'll see the same building now streamed to Unity. So we had a mobile, web, now Unity. And now let's say we want to do something else. We want to animate it a little bit. So let's click here. I will expand some of the things that we can have, so we can do. So for example, if I'll do direction equals right, adding some metadata to the content, bam, it will automatically start rotating. Super, super simple. And all I had to do is like add some data. If I want to make it bigger, because let's say it's small, I'll do scale equals 2. Bam, suddenly it automatically popped to be like twice the size. Super, super simple, just adding data. Another thing that I want to show you, so we saw mobile, we saw web, we saw Unity. I want to show you another web example that is pretty easy to use. If you access the same console just through your phone, so that's what I'm going to do. I'm just going to go to our website and log into the application. Let's see that. I'm going to just sign into the same console just on my phone. Let's sign in. Perfect. We'll see the same building right here. Here I have this cool icon. It's automatically quick viewing it in AR. Let's press that. The camera again will open. I'll do view in space, and bam, we'll be able to see the same building on the floor right here. Super simple. I'm able to scale it with my hands, just like pinch it a little bit, and there you go. So super simple example, again, of how you can just like drop and drag something, and automatically you're able to see it on mobile, web, and everything. So definitely use that. As people mentioned in the comments, you can do exactly what I just did by following our documentation. It's accessible here, or just docs.echoAR.xyz. Literally a step-by-step guide on how to do exactly what I just did. Drag and drop 3D models, see them in AR. We also have some coding examples right here that you can use to get you started. And you can register for our Slack channel to ask questions from our support team that will be happy to help you. We have a question in the chat right here. Jumping from touchscreen to more to web from personal opinion, go on to say that jump from touchscreen to AR/VR is bigger, more fast. Well, you can use AR/VR on web, mobile, regardless. Obviously, there's a big wow factor here on how to, like, when you create experiences, specifically now for hackathons or for builders. It's amazing. Like if you want to build some AR or some app, any app for any industry, having that AR/VR camera component is pretty phenomenal. Like it has this amazing wow factor, and we'll talk about use cases later down the line. So up until now, we saw a lot of examples of AR where the camera recognizes the floor and adds the 3D models on top of it. That's called surface detection. The camera basically triangulates some kind of surface, like a wall, a chair, or a floor, and overlays the content on top of it. Another thing, another technology that we support is called image recognition, in which the camera recognizes a specific image and then overlays the content on top of it. So that's what I'm going to do right now. And actually, you'll be able to see that 3D model right now as well. So when I click here, I'm going to open this QR code. You can actually scan it with me. So if you have a phone next to you, do the same thing I'm going to do right now. I'm going to scan this QR code with my phone. Most phones already have, this built-in QR scanner. So there you go. I'm scanning this QR code. It will instantiate a website. Like I'll be redirected to a website. You'll have the same thing. It might be asking you to allow camera access. Keep your phone oriented towards the QR code. You'll see automatically, bam, the Empire State floats from the screen to your phone. So let me check it out. Scan the QR code with your phone. redirect to a website, allow camera permissions, and keep your phone oriented on the QR code. And you should see that in first stage floating literally in front of you. Super simple example of how you can do things in QR. And see the difference? Earlier, we had the content overlaying the floor. Now we have the content overlaying the screen, basically overlaying an image. That image can be anything. Right now, it's QR code, but I'll show you in a second how you can have a custom image to basically allow it to be your business card. Allow someone will scan your business card, suddenly they see a video of you talking. We sponsored another hackathon in which a cool group created this COVID tracker. People would scan QR codes around town. You're able to get like some informational videos on like the surrounding, but actually it tracks on the back end how many people scanned it. Are they enforcing social distancing, stuff like that. So perfect. So hopefully you got a chance to scan the QR code and look at it. Now I'm going to do something really cool with a custom image. So let's do the same process. I'm going to close this for now. I'm going to upload, instead of a model, I'm going to upload a video as well, because I mentioned we support videos too. So let's do that. I'm going to upload, let's do this MP4 file, super short animations. I'm going to, instead of doing anywhere, I'm going to choose on an image. So basically add an image file for us to convert and make sure the camera recognizes it. So I'm throwing an image inside, pressing next. Again, we upload that content to the cloud. We convert those videos. We convert those images so they'll automatically work. Once that's done, we're going to do the exact same thing that we just did. We're going to open the camera, scan this QR code to basically instantiate the experience. So let's do that. Perfect. Again, we'll be redirected to a website. You don't have to install anything, no app, no nothing. It's literally all through the web. Once that's done, the camera would open, but now it doesn't recognize the QR code anymore, right? Because I uploaded an image. So let's open that marker. Let's press it, do marker, and there you go. We see that the image is only overlaid with this video that I can play. Super, super, super simple. Right, we have this video. We had companies doing like virtual museums that you can like scan images. We have a bunch of examples again on our GitHub that you can play around with. For example, if you want to build a freaky museum, there you go. You can do something like that, basically putting images, and suddenly they're coming to life with that video. So definitely check out these examples on our GitHub channel. So we saw mobile, we saw web, we saw Unity, we saw image detection, we saw surface detection. Let's see if we have any questions so far. Where can I get a project key for echoAR? Great question. So if you can see, this is, I'm going to share the link again. You're going to get free access to our premium tier by registering here. Once you use this link, you're going to get an API key through your email, but you also just allow it to scan, you allow it to get that API key, and then you'll be able to log in into the system. So just make sure you do that and check your email or spam folder sometimes. How exactly does this software scan the floor? So we're using a lot of AR SDKs that like companies like Google, Facebook, Apple have built. They basically triangulate the floor. They match 3 points that they find, and they basically understand, the camera understands through computer vision algorithms that this is the floor, and then the AR kicks in, and we're able to place 3D models on top of it. Great question. What is your GitHub username? The account with all the examples? Yeah, okay, so it's called echoAR XYZ. It's right here. I'm going to share the link right here as well. But again, make sure once you get access to the console, everything is here. So you can press on this quick icon. You'll get the documentation. You get the GitHub. You get our Slack channels that you can register and get people to basically answer questions on our support channel. You can email us, tweet us, anything goes. Perfect. Let's explore the console a little bit more. So again, recapping, we saw web, we saw mobile, we saw Unity. We'll look into Unity later a little more. We have a question about using, yeah, you can use AR Studio. That's fine. If you use our Java SDK, that works with Android Studio. I personally recommend Unity because it's really good to do like cross-platform apps. Like you can do them for Android and web, Android and iOS as well. And later I'm going to show you how to do that. But if you were adamant of using Android Studio, you can do that, and that's the Java SDK. But if you know Java, it's really useful to do the same with Unity, because they're both like Unity uses C# and they're both like object-oriented languages. So if you know Java, you're going to translate it really well to C#. Josh is asking, would you recommend Flutter? We have an example code for Flutter. To be honest, personally, I love native Unity, but we do have an example code for Flutter right here that basically has Flutter, it has Unity as a library and our SDK already embedded. So definitely check it out. I think it has Android integration. Definitely check it out if you really want to do it in Flutter. But I usually recommend like native Unity with our SDK. Perfect. So let's explore if there's no other questions, can we create AR filters? Yes, you can. All you have to do is, again, just, again, recommend you to start with the Unity AR Foundation example that has face tracking as well built in. You can use AR Foundation as the AR SDK to recognize faces and basically overlay data with it with Echo. So basically add masks, add 3D models, whatever. So definitely check out this thing. Perfect. So let's explore the console a little bit. So we saw this is your key that you load. These are the downloads that you can have, example codes at GitHub. We saw the help menu. We saw that now let's see that we can switch themes, light, dark. Obviously, dark mode is default. We can also have basically manage the data. So like as we saw earlier, I'm able to manage data per model. So here I'm able to add some model, but like the source, the height, the scale, all that. I'm also able to add data on a project level, on the project level thing. So basically we work, for example, with companies who built in scavenger hunt in AR. It was basically a really cool crime scene investigation thing. They had different scenes. So each model would correlate to scene. So you have like scene equals 2, scene equals 3. But you also have like this global database of all the scenes, like something that affects all the scenes. So you can add data here as well. When it comes to payments, this is a really cool page because it shows you like your plan of usage, how much API calls are you making, what storage you're using, how much bandwidth you're using. You're all going to get this tier for free if you use the link that we shared, so definitely check it out. Able to cancel your subscription, manage your subscription, stuff like that. Locations is another one. Oh, I forgot to mention that. So let's upload another like 3D model, but let's tag it with location now. So I'm going to use either my location. Let's plug in some specific location so you'll see. So you'll see that it works. So I'm going to change this thing. I'm going to add New York as the tag. There you go. And basically, we tag that data with the location. That means that if you open one generic app, you can make a cool app that if it opens in New York, it will show you the Empire State Building. But if it opens in San Francisco, it will show you the Golden Gate Bridge. So obviously, like super simple examples. But that's another layer of data that we understand. Okay, so 3D models have this contextual awareness of the space that we're in. So like this fox now resides in New York. And now when I go back to the location page, I see, bam, I have this fox here located in New York. And this map is really cool because it will be able to see like the distribution of content, where you're placing objects across the world. You're able to see what servers we have, the support streaming of that content, super, super simple. And once people actually start using your application, you'll be able to see where you get most engagement. For example, you're getting a lot of traffic for models in New York, a lot of traffic for models in China, whatever. We also have the setting feature. It basically allows you to control a few settings like security. Don't worry, everything is anonymized. Everything is through SSL. So like your data is totally private, and you're able to add other users to your project. They're getting an email once they register. Insight is a really cool page that basically allows you, again, to see how much people are using your application, how you're using the content. For example, we streamed the Big Bug Bunny, so we get a spike right here. We're able to see the most used content that we have, some data on like how much people are using the application and like the console. So definitely check that out as well. Users, it's a really cool screen that basically shows you where your users are coming from. So you're able to see, oh, a lot of my users are in Mexico. So maybe I should hook up a server in Mexico to make sure it will stream. Someone was asking, how near are we to create completely developed holograms? Those already exist. They're not as prevalent like in everyone's home, but like you have avatars and 3D representations and 3D scans that are like literally lifelike that you can stream in augmented virtual reality. We actually have a demo right here for remote work that basically has like a really lifelike avatar of a person being scanned, and you're able to interact with it as well. So definitely check out that example code and start building something cool with that as well. Another page is the tutorial page. It's a really cool page that asks a lot of frequently asked questions to direct you to the documentation. And the documentation will basically, again, go step by step to do exactly what I just did. So make sure to follow up on that as well. And my favorite page is the inspiration page. This page is filled with amazing examples of augmented and virtual realities that you can build. A lot of projects that were built with Echo, some were, some not. Things like a project we did with Verizon, or Google's remote navigation, or the art installation that I mentioned, or the mystery game that I mentioned. So many cool projects like games and medical and furnishing and indoor navigation and retail. So definitely check them out to get some inspiration. They're accessible here. Once you register and get access to the console, you're able to see all these amazing projects and get links and inspiration. So definitely check them out. Some of them are phenomenal. Recently, we added a few projects that people built during hackathons. So if your project does well, we're happy to feature it here. A lot of people did like really cool applications around COVID and like visualizing data specifically for COVID. So definitely check it out. And later, I'm going to show you another coding example with COVID. Perfect. Any questions so far before I move on to a more technical part of basically showing you how to use Unity to build an application? So if there's any questions, feel free to write them here in the chat. Okay, so let's give Unity a second to load. I'm going to go back here and allow you, if anyone wants to scan the QR code again with their phone, they can do it right now. I'm going to leave it for a few seconds while Unity opens. Let's see if that's loading. Give it a sec. Okay, so let's recap the slides where Unity is opening, and then I'll go back to Unity. Oh, we have a question. Can you elaborate a little more about examples, how you can integrate this with a Java and Android Studio? Yeah, sure. So all you need to do is download this Java SDK. You'll get access to basically a wrapper for our API. So our API is documented really well here. And the Java SDK basically wraps that API, allows you to do all these queries. Once that's done, you're basically automatically able to fetch data, fetch 3D models, show them in AR. Specifically with AR Studio, with Android Studio, you'll have to integrate ARCore. So I'm going to write it here, ARCore. That's Google's AR SDK, like the one that spawns the camera. So make sure to just add that as well, and you're good to go. We have, which file format did the software use? So we support any 3D model. So it's OBJ, FBX, GLTF, USDZ. And our platform also automatically converts everything to everything. So like this 3D model is an OBJ, but you see that automatically our system converted it to GLB and USDZ automatically. FBX is on the first one to convert. It's really easy to actually find 3D models. If you go back here, and let's say you want to search for something, we obviously allow all these different samples that you can have, but if you want to search for something specifically, like, I don't know, like a globe, we can just like click here and we'll search the 3D models from other content aggregators out there for free. So you're able to search poly.google.com, Sketchfab for free 3D models, and there you go. We have the results for a globe, and you can use all of them in your presentation, in your application. So definitely check out our search engine. Again, we utilize content aggregators like Sketchfab, Poly. There's a bunch in the add a model. We have a list of a lot of free 3D model aggregators like poly.google.com. That's like Google's search engine for 3D assets. So if I do building, right, I have all these buildings that I can use. The same way you just saw, I just like threw in some building and I use that. Sketchfab is another one cool website that you can use. We have TurboSquid here, so like definitely check out our documentation for more information on that. Perfect. So we saw web, we saw mobile. Let's see Unity. So if you download our SDK right here, it will just download the file that you can just double click it once Unity is open, and then bam, you can see Unity. So Unity is, again, it's a game engine for developers who want to build AR, VR applications for either Android or iOS. So it's cross-platform. Really recommend to use it. People are asking what stuff one really familiar with. Again, Unity, I think, is like the best thing. Experience-wise, it's interactions, making sure that it's clickable, and we'll see how to do that again. So what we have here is Unity. It's a game engine. Here we have an empty scene. There's nothing here. But once you integrate our SDK, literally by just double-clicking, we'll have this sample scene. So I'll just go echoAR examples and then sample. This is the sample scene. Once that's open, I'm just going to plug in my my API key that I have. You can do the same. Let's press play once that's done. And we'll see that now the content will be streamed automatically to Unity as well. So you're not going to be surprised to see, hey, there's our building. And the fox is here as well. Here's the fox. Here's the building. Let's move it a little bit to the left and this to the right. But let's say, okay, so we see that the fox is a little obstructed by the building. So let's go here and add x equals 10. Bam, automatically the fox moved. Let's do the direction that we did earlier. That was fun. Direction equals left. Bam, suddenly starts rotating. So super, super simple. There's all these like built-in keywords that we add for interaction. Going back to the question in the chat, what things you should know. So interactions, animation, these are really, really cool things that you should do in Unity. The cool thing is that once I stop Unity, like once I close the application, everything disappears. The content is not actually persistent. Like it doesn't stay on your phone. That means your app is super, super small and the data is being streamed from the cloud all the time. Does echoAR support .blend? It does not, but you can export .blends to OBJ GLTF and then upload those, or FBX. So now when I press play again, the same data will be streamed automatically to Unity. And the cool thing is that, bam, suddenly we have the same scene being recreated automatically, and all we had to do is just see it here. So I just press play, suddenly the same scene came back to life. And again, let's stop that, do that again. Bam, we have the same scene here. So this is really cool for when it comes to persistence. You're able to build something, able to move it around, and then every time someone opens the app, they'll see the same thing. Really, really cool and really, really powerful. Now let's do something. Any questions, by the way? If there's any questions, again, feel free to write them down. Just add them to the chat. So we saw this example of how you can do, again, like no code kind of things with Unity, super easy. Once you have that, you can build the project for Android and iOS and Windows and PlayStation, whatever you want, or Windows, Mac, you name it. We have, again, all these example code here. So definitely try playing around with them because we have them right here. Let's do a quick coding example to see how we can add features, add interactions. We're going to do something super simple. So every time a 3D model is instantiated, it has this this script attached to it called custom behavior. Let's open that up. So this script is basically a Unity script written in C#. So if you know Java or any other coding language that is object-oriented, you'll have a breeze of using it. Will you be able to access the recording of the meeting? Yes, no worries. We're going to share the recording of the meeting with you. And also remember that you can always refer to our documentation that will literally guide you step by step on everything that I just did. Like everything is here as well. But we'll share the recording, no problem at all. So let's go back to Unity right here. And we starting our coding example. So we have this two really, really important functions. One is start. So the start function basically happens when the application starts, when you press play. As opposed to update, that's a really interesting function that happens every single frame. So remember, you're building an application in 3D. It's computer-generated imagery. You have frames being rendered every millisecond. And that means that this function is almost like an infinite while loop, like while true, or like an infinite for loop that happens every single frame. Everything that's in this function is being instantiated and being executed. So make sure to write really concise code there so you won't overblow the performance of your application. But now we have this cool example. We see that when the application starts, we're adding some data to the entry. So like we're adding to this game object, we're adding this remote transformation script that allows you to rotate, to scale, whatnot. But we also look for some additional data that the entry has. And if it has a name, then we take the name and we set the name to be whatever we set it to. Super simple example, super simple. Let's see how that works. So now when I press play and we don't have that key called name in our data, the fox is being called just Arctic fox, right? Boring. But let's change it to something else. So let's add a data of name equals, what's a good name for a fox? Let's do Kevin. We have a fox named Kevin. Now when I press play, you'll see that the fox name in the object screen will actually be Kevin, right? Super simple. All I have to do is just like click a few clicks and add that one line in the script. Perfect. But what happens if I change the name now? If I use Sam, nothing happens, right? Because that function exists in the start. That snippet of code exists in the start function. So basically, it only happens in the beginning. So let's see how we can change that. So if we go back to the code and we grab this code snippet and we put it in update, which means this will happen every single frame, and now we're going to run it, we'll see that things will be able to change all the time, because it's basically checking for that name every single frame. So now when I press play, so let's do that. We see the same fox. Now it's called Sam because it's named Sam. But if I change it back to Kevin, bam, suddenly it's Kevin. If I change it back to Sam, suddenly it's Sam. So super, super simple example. But this is how you can like fetch data, understand data, add conditional features or conditional flows in your code based on data that you stream from the cloud. Any questions about that? So all we did is like we added data. We made sure our script knows to query for that data using this line and basically do something after it gets the data. And it can be, as we saw, it could be anything. It could be rotating, it's changing names, it could be animating it, you name it. It's a really, really powerful tool for you to, if you want to have conditional features. Let's say you want to enable a feature after you release it. So you can create the feature, put some flag, and then just basically add more features later. People are asking, can we make physics simulations in Unity? Yes, you can. Unity has an amazing physics engine. You can do collisions and gravity. It's really, really robust. Unity is a fully fledged game engine that you can use that has everything you need to think of. And with echoAR, you're able to stream data to it. So definitely check it out. It has amazing physics simulations inside. Again, colliders and gravity, it's pretty remarkable. Okay, so we did a really simple coding example. I'm going to move on to more advanced coding example. Don't worry, it's not going to be that insane. But let me delete the previous entries that I have right here. What I'm going to do now is I'm going to recreate a sample code that we have here for you to see, and then we're going to go through it together. But it's really a cool COVID visualizer. I'm basically seeing things, but the source code is here in our GitHub. So I'm going to delete the previous entries. Let's delete them. I'm going to upload something else, a new model of the globe. As you saw, I was obsessed with the globe. So let's upload a file right here. Let's upload a file directly from here instead of choosing it. So let's do models, and I'm going to choose this Earth file. Uploading to our cloud. Again, same process as always. We take that 3D model, we make sure it works everywhere. If it's Android, it's iOS, you name it. Let's give it a sec to upload. Now what I'm going to do, I'm going to cheat a little bit. I'm going to swap out the custom behavior script. So let's do that. Let's swap out that script here for a sec. So let's swap it out. There we go. So I just swapped the script, so we'll have something else. Let's add some metadata here. Let's scale equals 2. Let's make it bigger. Perfect. So let's play. Let's see our 3D world being rendered automatically right here. Perfect. So we see the world. Oh my God, look how amazing it is. Hopefully you're all safe and secure in this amazing plan that we have. Let's make it rotate because obviously it's the world. So let's do direction equals right, like we already know how to do. Perfect. The world now rotating. Super cool. Super amazing. Now I added some code to the script. So let's go through that together and see what functionality we're able to create. So we have the same, start and update function that we used to, but I also added data for continents. So basically, I defined some continents here, and then I'm going to add data based on all these continents that will affect the 3D application. So for example, right here, I have graphs being instantiated per each continent. So the start function is the same, but the object function checks, for example, it goes through all the continents. If it has a value for a continent, it will instantiate a cylinder, basically a bar graph, to add more information next to the globe. It will place that bar graph, it will transform it, make it as big as the value that we queried. It will color it, it will add text to it. Super simple stuff. Any chance we can mess around with the speed of rotation? Yes, you can. I'll show you in a sec how we do that. So let's see that. So now we have the script. Let's see what it does. So let's gonna add some content. So let's add these data points that we saw that our new script needs. So I'm just going to add some continents with some numbers. No worries. Just plugging in some data that I know that this needs. But again, you can have anything you would like. Perfect. And now when I press play, oh, okay, you already saw a preview. But now when I press play, we'll see we have the world, but also has this graph of like how many people were infected, for example. So super, super simple. All I have to do is, again, that script that queries all this data. And once it gets the data, it instantiates a bar graph at the size of 6, 10, 1, or whatever. If I delete, for example, let's delete Antarctica because it's like really big. Bam, it disappears from here because, again, our script does things automatically. Super, super simple example. All I have to do is like inject that data. Let's see. Any change? Oh, yeah. So let's do the rotation. So the rotation, as I mentioned, is controlled in this script called remote transformations. Direction is here, right? So we're querying for direction. If it's right or left, it transforms things based on location. There's a factor right here, like now it's 150, but if I'll do 1,000, let's do that, and go back here, and then restart that, you'll see that it should rotate much, much faster. So let's do that. Look how fast it rotates. All I had to do is like, change that factor. If you want, you can export that data, like that factor of rotation, that speed, added as a, as a parameter, and then query that parameter and set that as a number. Super easy. Can we revolve in any? Yeah. So there's, if you go to here, there are built-in into our Unity documentation, edit the code, and then underneath, we have different data points. Let me find that for you all. Let's do X angle. I think that's one. Yeah, transforming content. I think that could be. Yeah, so we have all these different keys that we can use to transform the content. For example, X angle or Y angle will allow you to basically change things and rotate them. So let's see how that works. So let's put the building again. It will stream automatically here as well. And then let's do X angle equals, I don't know, 25. Bam, suddenly the building rotates 25 degrees. So whatever you want, you just like make sure to change that and update that. Super easy. Another question that we had got here is, so ultimately all you need to do is learn C# to mess up with that. Again, like the things that I did are pretty simple. Like you don't even have to know C# to build that, right? Like I just added like really snippets that you can follow from our documentation. You don't have to have like an extensive knowledge of C# to do that. Perfect. So any other questions before I would go back to the slides? So let's recap here. We had different examples of how we can use Unity, different examples of code. We saw a cool example of a Kovat visualizer that you have the source code right here. Just follow the instructions that you have on our Git or obviously on our documentation. It literally goes line by line. And again, we're going to share this recording as well with y'all. OK, so if there's no more questions, I'm going to go back to the slides. OK, so recapping, what do we have here? So we saw how you can use any SDK, if it's Android, iOS, Magic Leap, HoloLens, you name it, web as well, to build your application. Content gators can just drag and drop some content. Automatically it works in Android and all these different platforms. We take care of all the building, storing, and delivering of content to headsets and mobile devices anywhere on the planet. As I mentioned, developers save time and money to build their applications. All you have to do, again, like you don't have to hook up a server. You don't have to connect your app to the cloud. We do that automatically for you. Content creators need no technical skills. We saw that 50% of my talk today was all no-code stuff. You just drag and drop stuff and it works. And companies can scale to enterprise level. Again, you can stream your data to China, India, the US, anywhere you want. Let's talk about some use cases. So we saw, we talked about the surgery one worked for healthcare, but we also touched about retail and shopping and tourism and ads and games, obviously, and interior design. These are amazing things that you can build in 3D. And again, I reference you to our inspiration page. There's so many things that you can build with 3D content that is, as you saw, like it's free. You can use free 3D content and videos and build really compelling applications. So definitely let your imagination run wild. You're only limited by your imagination here when it comes to 3D. So definitely check it out. A little bit about us. So we are a company based in New York, fortunate enough to be sponsored and backed by the most amazing investors in the country, from Techstars to Imagine Ventures to Verizon. We won a bunch of awards as well, so definitely check us out. And we're in all these amazing tech events. So once things go back to normal, and if you're going to some tech event, make sure to say hello, find our team, and interact with them. We're trying to engage the community as much as we can. And we like to say that we are building the track to facilitate all these horses in the AR space. We're trying to build and to control your camera. So definitely build a product once, and then you're able to scale to all of these. People are asking, what does exactly do spatial recognition? Spatial recognition is what I mentioned, that the camera recognizes a floor, recognizes a surface, recognizes your room, and then it understands that your room, the scale of it. Then we're able to, as I showed you, put the Empire State in it. A lot of companies are we work with a company who tried to scan buildings and then overlay them, if it's for construction, for example. We scan the building and then we overlay that building with a 3D model of the building, how it will look in 10 years or 5 years or 2 years after it's done building. So this is a part of the spatial recognition aspect of it for construction, for example. So again, register for your API key on our website, or use the link that we shared, or your hackathon provider organizer shared with you to get free access to our premium tier. Make sure to join our Slack as well to ask questions and get support. We're going to share this video as well on Slack and on the hackathon Discord or chat, whatever platforms we're using. If there's any questions, happy to help. So please write them in the chat now. This was echoAR, again, a cloud platform to help you build and deploy 3D apps and applications, 3D apps and content in AR and VR. We're super obsessed with helping developers and creators build applications, so definitely feel free to reach out. You have my email up there. And also, again, the Slack team will be on it if you're going to ask questions. I'll be going to be there as well to answer any questions that people have. If you have any questions, please feel free to write them here in the chat. If not, thank you so much for joining this workshop. Stay safe and healthy and build amazing stuff in AR, VR. Looking forward to see your projects, to judge them, and hopefully, again, one of you is eligible to win the prize after you build the application with our tech to be eligible. So definitely build something cool for us to enjoy and feature in the inspiration page. So thanks again. Stay safe, healthy, and start building amazing things. Thank you so much.